All right, so this is my problem 50, a week 7 video explainer. So in this problem, we are dealing with a rocket that's burning fuel at a rate of 5 kilograms per second and expelling exhaust gases at a speed of 4 kilometers per second relative to the rocket. So for this first part, we are trying to find the thrust of the rocket engine. So first what you can do is to understand that force can be represented as the change in velocity over the change in time times the mass. So another way you can also look at it is seeing it as force is the rate of change of momentum per time. So you could differentiate the momentum equation, but I found that to be kind of a little more complicated, so I just figured I'd just go the other route. So the thrust equation is going to be pretty similar here. However, instead of delta V, since we know that the pellets are going to be starting at rest, that exhaust velocity is just going to be equal to delta V. And I kind of wrote it out right here. So since the pellets start at rest, the change in velocity is just going to be equal to the exhaust velocity. As like I said, they're starting to at rest, and this is relative to the rocket. So an equation that can model this is going to be the thrust force is going to be equal to the change in mass times the exhaust velocity over the change in time. And then for the second part, we're trying to find the rocket thrust for the values that were given before. And a couple things to note is that if the rocket is moving, the exhaust velocity is no longer the pellet's speed through space, but it's still the speed relative to the rocket. So one thing to understand in this problem is that as the delta M and delta T values are approaching zero, it could also be represented as the change in dm over dt, which is the change in mass over the change in time. So going back to that original equation, we know that the change the change in mass over the change in time was given to us, which was 5 kilograms per second, and then the change in velocity is 4 kilometers per second. So this is going to be 20 kilonewtons, and it would be 20,000 newtons if you want to convert it. But yeah, so that would be the thrust force for those values. And just some of the things, how this relates to this week, was it just goes to show how, or I guess it just describes more about how different objects interact. It talks about Newton's third law and just more like propulsion and tension forces. So yeah.